This is a continuation of illustrating cluster points of a set. In the previous video, we're able to present 4 different sets and give short discussions as to how do we identify the cluster points. This time, let's have another set. I will be giving you 3 different forms of a set here, and we are going to identify the cluster points of the given set. Let's have this set. We will have here the union of the set of rational numbers, the intersection of the set of rational numbers and the interval 0, 1. If we're going to come up with a real number line, of course, 0 and 1 is here. And when I say about the intersection, it includes everything here as long as they are elements of the rational numbers. So how do we identify the cluster points of this given set? To identify the cluster point, as mentioned, we should find any value of C. Cluster points are C, element of real numbers, may not be an element of set A, or may not, as long as it's a real number, where once we locate that C there, okay, no matter how small the delta is, minus delta and plus delta, on that interval, we could locate certain points x sub 1, let's say x sub 2, which are element of set A. If we they are not necessarily equal to C. Okay, they are distinct from C. If we could find that, that would mean the said C is a cluster point. Now, if we're going to pick something here, take note that there are infinitely many rational numbers between 0 and 1. Okay, say for example, we'll have this C being, let's say, it's not 1/2, so let's just assume it's 1/2. Okay, now once you take, no matter how small that delta is, okay, you could always find x sub 1 or x sub 2, which is a rational number that is actually still an element of A. One of which is, of course, you can give there, I don't know if 1/3 is, or you can say here, you can have here 4/9. 4/9 is less than 1/2, but it could be part of that value, and 4/9 is still an element of A, which is the intersection of the rational numbers and this. So all of the entries inside here are counted. The next thing here is, how about the endpoints 0 and 1? We already discussed this in the previous video. Even if 0, as you look for, no matter how small delta is, even if some of them will be outside, the point there is existence, okay, at least 1 point, and that 1 point may be here, very small, but it's still part of A. We are to count the endpoint as a cluster point. Even if 0 and 1 are not elements of A, cluster points may or may not be element of A, as long as the excess that is considered to identify cluster points should be an element of the set A. In this case, the cluster points for this is the closed interval 0 and 1. Okay, so that's the rest of the cluster point. And of course, we know that the set of rational numbers is dense, so there are infinitely many items there. Okay, let's proceed to the next example. Let's have B. And let's have this set. We have 1 over n, such that n is a natural number. So we don't know the exact value of this, but of course, once we break this is a sequence, you will have values in this manner. So when n is 1 is 1, 1/2, 1/3, 1/4, 1/5, and so on and so forth. When you look at this set, this is similar to example B as well on the previous video, where it's we have specific items, because if you're going to have it in real number line, say for example, here is 1 and here is 0, so you have here 1/2, so 1/3 is somewhere here and 1/4 is somewhere here. Take note that the distances between them is not part of the set, as it only includes the natural numbers. Okay, so with this, there are some portions here that are not included. So how do we determine with the cluster points? Number 1, in our discussion before, these points here, okay, these points, this point, this point, 1/2, 1/3, and so on and so forth here in between, are considered to be non-cluster point, because when you look at 1/2, no matter how small your delta is, and you will have that, you would find here points. But these points, let's say x sub 1, x sub 2, x sub 1, and x sub 2, are actually non-elements of B, in this case B. So that would mean this 1/2 is not a cluster point because it should be element of the same set. This is true with 1, 1/3, 1/4, and so on and so forth. But what would be the cluster point if that is the case? 1/5 is also not, 1/6, 1/7. There is only one cluster point for this. The sole cluster point, that's why it's called cluster point, because there's only one, is actually 0. Now 0, yes, is not an element of B, but cluster points may or may not be element of the set. But the point here is, if we're going to pick 0, okay, going to pick 0, and you're going to have delta, no matter how small delta is, you would see here elements getting closer to 0 that would fit the criteria, or that would be an element of set B. Consider, say for example, just in assumption, 1/210. That's very small. It gets closer to 0. So for any delta, it is a possibility that that would be contained on that range. Take note that we are doing this x minus c, less than delta. The distance between c and your x identified is less than delta. It would fit the criteria even if 0 is not part of an element of B, but what you find here are elements of B. So say for example, this is an element of B, okay, and it would fall into this criteria, hence 0 is included. It's only 0 for this case. Okay, now let's have our last example. Let's have a little bit complicated example here. Let us have set E. We have -1 raised to n plus 1 over n for n element of set of natural numbers. So similar thing earlier, we can identify some of its elements here. So for n is 1, you have -1. When n is 2, this becomes positive 1/2. Sorry, so this would become positive 1/2. When n is 3, -1/3. When n is 4, 1/4. When n is 5, -1/5. You have here 1/6, and so on and so forth. So what would be the cluster point of this? Again, in a real number line, so if this is your -1, this is your, say for example, 0, this is 1. So the points here are this. So you have -1, positive 1/2, you have -1/3, okay, -1/3. You will also have positive 1/4, so the positive 1/4 is somewhere here. So -1/5, assuming -1/5 here, 1/5, and you will have 1/6 here as well. Now, when you look into this 1, okay, this is similar to the previously discussed item where the points here, this one, are non-cluster points. However, when you look at this, okay, when you look at this and locate delta, no matter how small, you would not find any entry here. But if you're going to extend, because delta just be greater than 0, so you could also have large delta where you could include 1/3 here. Okay, so with that, -1 is included, because delta may not be just small, it could be very large, as long as it would include an element, or this is an element of C. Okay, this is also true with 1 here. So just by coming up with delta, just like that, it may include 1/2. So for this item, we only have 2 cluster points, and that would be -1 and 1. 1 is an element of B, 1 is not, but as you look for delta here, it may include this as element of B, hence we can consider that as a cluster point as well. So this is how we identify cluster points of a set given these forms. Thank you very much for watching.